Hello student, I'm back after a long time in this pandemic COVID-19 situation. So today I've come with an important topic, that is Laplace transform. Now what is Laplace transform? Nothing but it is an important tool by which we can go to time domain to S domain, where the Laplace variable S is a complex variable defined by S equals to sigma plus j omega, where sigma is in the real part and j omega is the imaginary part, where we all know that j square is equals to -1. Now if we draw a S plane, as you can see in the figure, the real axis, that is x-axis, is defined as the real axis, that is sigma, and the y-axis is my imaginary axis, that is j omega. This j omega axis or imaginary axis dividing this S plane in two halves, that is right half plane and left half plane, that is denoted by RHP and LHP, and the overall plane is my S plane. So what about that point? The center is my S equals to 0 plus J0. Now I am going to find out some Laplace transform by the easiest way, that is by using the simple Laplace transformation and Laplace inverse transformation formula that is given by this. The first one is, if the xt is given in the time domain, we have to calculate the xs, that is in the S domain. That is, the formula is integration having a limit of -infinity to +infinity xt e to the power minus st dt, and whenever there xs is given in the S domain and in the time domain, it is given like that: 1 by 2 pi -infinity to +infinity xs e to the power plus st, and the parameter is ds, right? So first just going to solve this one. Xt is given in e to the power -80 ut, and I have to calculate xs, and I need to find the ROC, that is region of convergence. So here is the formula of xs. So I am just substituting the value of xt that is given in my question, e to the power -80 ut, like that, and with that e to the power -st dt. So what is ut? Ut is, we all know, unit step function, where just like that, where ut is having an amplitude of 1 when time is greater than or equal 0, but whenever the t is less than 0, it is having an amplitude of 0. So this expression is reduced to 0 to +infinity e to the power -80, ut is value 1, so e to the power -80 into e to the power -st dt. So it is becoming like that. So after solving, it is coming, and putting the value, it is coming 1 by s plus a. Now we need to calculate the ROC. As you can see, that is my ut, where t is greater than 0. So in that case, ROC is that denominator s plus a will be greater than 0, so s becoming greater than -a. So if I plot here in the S plane, -a is obviously in the real axis, so s greater than -a means this one is my ROC, that region starting from -a to the +infinity. Now I am taking another example where xt is equals to -e to the power -80 u -80. You can see, if you solve this problem again using the same formula, it will again become 1 by s plus a. But as this is u minus t is there, the previous one was ut, but here it is u minus t, so in that case the ROC will be my s plus a less than 0, so s becoming less than s plus a less than 0, so s is less than -a. So in that case, suppose this is -a, this is my sigma plane, and this is my j omega axis. So this one is my ROC, where is less than minus a. This is the difference of using that ut or e to the power minus u minus t. You can see the Laplace transform is same for both the case, but the ROC is different, right? Now we are having another problem, xt equals to e to the power minus 3t ut plus e to the power minus 2t ut. In that case you can see it is almost equivalent to this, but there is an addition of this type of parameter. So as the e to the power minus a t ut, there was a Laplace transform 1 by s plus a, so I can write, after solving, I'm in doing it in shortcut, that is 1 by s plus 3, and it will become 1 by s plus 2. So there are two different terms. So what will be my RAC? That is the main question. What will be my ROC? So in that case ROC is obviously s greater than minus 3, and in that case ROC is obviously s greater than minus 2. So if we draw a plane, suppose this is minus 2 and this one is minus 3. So for the first term the ROC will be like that, and for the second term the ROC will be like that. So what is the common portion of both the ROCs is s greater than minus 2. So it will be the overall ROC. So ROC will be obviously s greater than minus 2. So if I am drawing it in a fresh, so this is my ROC is greater than minus 2. In same way, suppose xt is equals to e to the power minus at ut plus e to the power minus bt u of minus t. So here again e to the power minus t. So if I solve this one again, it will become 1 by s plus a, and this one, but in that case ROC will be s greater than minus a, but in that case ROC will be s less than minus b, and another condition was given that minus b is greater than minus a. So what will be my ROC? The common portion again. So suppose this is minus a, suppose this is minus b and minus a, so ROC will be in that region, the common portion obviously. So here you can see, I'm just doing this video first. There are properties of Laplace transform. You can take the screenshot as well. There is linearity, there is time shifting, frequency shifting, time differentiation, integration. For differentiation, for the first order it will be sxs and x0 minus. If it is second order, then s square xs, sxs, and the derivative of x dt. For nth term, the highest order will be xn, and the finally will be d of dt, but n minus 1. And similarly for integration, it will be divided by s. For integration it will be multiplied by s. For differentiation it will be divided by s. And then frequency differentiation, for minus txt it is dxs ds. For xt by t it is integration. For x at, that is 1 by a s, x of s by a. This is time convolution, and in the s domain it will be multiplied, and in the time domain if it is multiplied, and it will become convolution. And then initial value theorem, that is x0 minus is s xs, but the limit of s tends to infinity. And for x infinity it is again s xs, but the limit of s tends to 0. These are few very important properties, particularly in this differentiation, this integration, initial value, final value, convolution, scaling, and frequency integration, frequency differentiation. These are very important for any solve of any waveforms. Now I am going to solve a problem of initial value. My xs is given by 3 by a square plus 5s minus 1. I have to calculate the initial value of that one. So I need to use the initial value theorem, where initial value theorem states that x0 plus equals to limit s tends to infinity s xs, right? So limit s tends to infinity s xs, so xs is given like that, so s xs will become 3s by a square plus 5s minus 1. Now to as limit s tends to infinity, so we can write limit 1 by s tends to 0, so I can put the value of 1 by s equals to 0. So I need to convert that term into some functions which will have these 1 by s, 1 by s square, 1 by s cube, these kind of terms. So in that case, what is the highest power of the s from both numerator and denominator? Overall highest power is 2. So I have to divide both numerator and denominator by s square. So if I divide it by s square, it will become 3 by s, it will become 1, it will become 5 by s, and it will become 1 by s square. So whenever 1 by s is 0, so 3 by s is 0, 5 by s 0, 1 by s square 0, 1 by s cube, 1 by s4, all the things are 0. So it will become 0 by 1 plus 0 minus 0. So it is basically becomes 0. So that is the initial value theorem. The main tricks is you have to convert the function into a function of 1 by s, which will comprise 1 by s, 1 by s square, whatever the power it will be, and I can put the 1 by s is 0. Now I am going to solve some final value theorem problem. Suppose xs is given by 1 by s square plus 4. Final value theorem we need to use, that is x infinity, which is equals to 1 by limit s tends to 0 s xs. Okay, so I'm just putting the value of this. That is s by limit s tends to 0, s by s square plus 4. So if I put the value here, it is becoming 0, but that case, in that particular case, this value is wrong answer, as s square plus 4, 1 by s square plus 4, I can do this. S square plus 4 can be divided in that two parts, s plus 2j by into s minus 2j. So in that case, both the poles are in imaginary axis. Whenever both the poles will be in imaginary axis, the x infinity does not exist. Okay, so I'm going to find another one. Xs equals to s minus 1 by s into s plus 1. In that case, the x infinity is limit s tends to 0, s into xs. S into xs will become obviously s minus 1 by s plus 1. So if I put s equals to 0, it will become -1. So this is the final value of that particular function. Okay. Now I'm going to solve this problem, which is another use of the property. As you can see, the xs is given. I have to find y1s, where y1t is equals to txt. As I have already shown in the properties that what is the property? If the xt has a Laplace transform of x's, the txt will have a Laplace transform that is minus dds of x's. So as you can see, that txt is my y1t, right? So what will be the y1s? Y1s will obviously minus dds of xs, that is minus dds of s plus 2 by s square plus 4s plus 5. So I have to apply, that is u by v formula of the differentiation. So it would become a square plus 4s plus 5 whole square, that is v square, and then the differentiation of the upper part is obviously 1 into the v u du ds into v minus the u will be constant this time, the v will be derivative, so that is 2s plus 4. So after solving this one, it would become a square plus 4s plus 3 by a square plus 4s plus 5 whole square. So that's how you need to use those properties. Wherever it is applicable, wherever it is found to apply. So these are the few basics of the Laplace transform. I will come later in with another part of this Laplace transform, again with some harder problems, but before that I am again showing some basic formulas of basic standard signals. That is, the if the xt is del t, that is the xs is obviously 1. What is del t? That is unit impulse function. Whenever that is my unit step, that is 1 by s. For xt is t, it is become 1 by s square. For t square, it will 1 by s cube. So 2 by s cube. So 2 t to the power n, for t to the power n, it is xs is n factorial by s to the power n plus 1. We have already learned that e to the power minus at, that is 1 by s plus a. If there is a t multiplied, it will become square and the factorial of 1, that is t to the power n. So for t to the power n, it is n factorial and the power is n plus 1. For sine omega 0 t, that is omega 0 by s square plus omega 0 square. For cos s by s square plus omega 0 square. And if the e to the power minus at is multiplied with the sine omega 0 t, it would become like that, omega 0 by s plus a whole square plus omega 0 square. If the cos omega t is multiplied with that, it will become s plus a by s plus a whole square plus omega 0 square. So these are the few basics Laplace transform some standard signals. So in this video we have learned from few basics few basic formulas of the Laplace transform, the Laplace transform of some standard signals, and you have also learned how to use the properties of the Laplace transform, which I have already discussed. So thank you for today, and thank you for watching the video. We will come up with another video of the Laplace transform with more harder problem using the properties of convolution and also the inverse Laplace transform. So in that lecture we will learn how we can get the time domain signal from S domain signal. So thank you.